Hey everyone, in this session we will understand one of the most important topic of NumPy, which is multidimensional arrays. N-dimensional array is a multidimensional container to store items of same size and type. That means all the items has to be of homogeneous type. I have depicted few n-dimensional arrays. The first one is one-dimensional array, two-dimensional array and three-dimensional array. In our coding session, using Jupyter Notebook, we will write some code to create multi-dimensional arrays and we will perform some operations on top of. In real life, if you are interested to work on image processing, computer vision or video processing, you cannot escape multidimensional arrays because all these domains are heavily using multidimensional arrays for their computation. Apart from these domains, there are a number of scientific domains where you have to use multidimensional array to store the data or information in order to perform some computation. In NumPy, there are different ways to create arrays. We can use Python list or tuples to create arrays out of them. There are a number of NumPy functions using which we can create arrays in NumPy. I have listed few important functions and attributes in order to work with multidimensional arrays in NumPy. np.array is a method by which we can create multidimensional arrays using Python lists or tuples. We can create arrays of zeros or ones using zeros and ones functions present in NumPy. If we want to fill a constant number within a multidimensional array, there is a method for it. Using full, we can perform the same. During our coding session, we will understand all of these functions in action. Even we can create a random array using random function. Apart from these functions, there are a number of attributes using which we can access the properties of arrays. dtype is used to understand the data type of the items present within an array. Using shape, we can understand the shape of an array. For example, for this two-dimensional array, the shape is 2 cross 3, where 2 rows and 3 columns are present. ndim is another attribute by which we can understand what is the dimension of an array. We can understand the memory consumption of an array using nbytes attribute. During our coding session, we will also understand how can we access items from an array using either indexes or the slicing. These are the two things what we have already understood during our Python list session. Please go through the Python list video in my channel to understand indexes and slicing in detail. However, in this session also, we will write some code to understand how can we access items from an array using indexes and slices. We will also see two different ways by which we can copy one array to other. Using shallow or deep copy, we can copy one array to other. We will see the basic difference between shallow copy and deep copy. Let's go to the Jupyter Notebook. We will write some code to understand all these points in detail. Here in this Jupyter Notebook, we will write some code to understand how can we create multidimensional arrays in NumPy and the other functions in order to access items from a multidimensional array, and how can we copy one array to the other. To use NumPy, first of all, NumPy has to be installed in your machine. You can install NumPy using pip install NumPy. In my system, NumPy is already installed. That's why you will see requirement already satisfied in my case. However, if NumPy is not present in your machine, it will install it from PyPy portal. Please ensure you have adequate internet connection because it needs internet connection to install NumPy in your machine. Once you have NumPy in your machine, you have to import NumPy in this notebook to use all its methods and functions. Let's understand the first option of creating an array using Python lists and tuples. np.array is a method by which we can pass a Python list and the adequate data type, create an array out of it. If I run this cell, notice I have created an array using a Python list. Data type of each and every element is int 32. We can see the same using dtype attribute. Dtype will give you the data type of the items present within an array. Using shape, we can understand the shape of an array. As array is one-dimensional array in my case, that is the reason you can see the shape of it. Ndim is a property by which we can understand the dimension of the array. In this case, array is of one dimension. Let's create a two-dimensional array and see all the properties there. Using Python list, I have created a two-dimensional array where we have two rows. This is first row and this is second row. It means we have two rows and four columns in my two-dimensional array. Let's see what ndim prints. Ndim returns 2. By this, we can clearly understand that my array is of two dimensions. Let's see the shape now. We have two rows and four columns. That's why it is showing 2, 4. nbytes returns the total memory consumption of the array. In this case, it is 32. Why? Because we have 8 items and each item is of 4 bytes. Now let's check what are the other options by which we can create arrays in NumPy. NumPy offers a lot of functions using which we can create multidimensional arrays in NumPy. np.zeros is a function by which we can create an array of zeros. Zeros is taking the dimension of the array. By 2, 3, we are informing Python interpreter that we want an array of 2 rows and 3 columns. dtype equal to I means all the items will be of integer type. Let's run this to see an array of zeros. By default, I means int 32. Using ones, we can create an array consisting all ones. It takes the dimension again, which is 2, 2. That means 2 rows and 2 columns will be there in that array. Let's run this to see the result. By default, if you see, all the items are of float type. If we want to create an array of a constant value, we can do so by using full function. Full takes 2 arguments, the dimension of the array, and second argument is the actual constant by which it will fill that array. If I run this, you will see we are getting an array of all 7s because we have passed 7 as an argument of full function. We can even create an array of random items using randint method. Randint takes 3 parameters. The first 2 parameters are the limit of random item. The third parameter is nothing but the dimension of an array. Let's run this. We are getting an array of size 4 cross 5 and all the items are in the range of 10 to 90. But the items has been generated randomly, and that is the reason every time you will run this method, you will get a different array out of it. Now, once we have understood how to create multidimensional arrays either by using Python lists or tuples or by using NumPy methods or functions, let's see now how can we access the items of those arrays. The fundamental way of getting items from an array is using index. If you see here, I am using the same array underscore random array and passing 2 indexes here because array underscore random is nothing but a 2-dimensional array. That is why we have to pass 2 indexes to identify an item uniquely from this array. Let's run it. You can see it is returning 14. The indexes are first row and second column. Always indexes starts from 0, and that is the reason this row is 0th row and this row is the first row. I want second column of the first row. 86 is of 0th column, 39 is of first column, and 14 is the item which will be returned. 14 is stored in index 1, 2 of array underscore random. Along with indexes, we can even use slicing technique what we have used in Python list. The same slicing technique we can use accessing items from NumPy arrays as well. Here we are interested to fetch the items from first row and from column 2 till column 3, from start index till end index -1. So in this case, it will be fetching the item stored within second index and the item stored within third index. It will not fetch the item stored within fourth index. If you want to know more about slicing, I have a video called Python list where we have explained slicing in details. You can go through that video. If I run this, notice it is only returning 14 and 18. That means in the first row, it is only printing the item stored within second index and the item stored within third index. Let's run and print the item stored within array. Now we will be using more advanced slicing here. Remember, the slicing can take three different arguments separated by colons. First one is the start index, second one is the end index, and third one is the step size. In this case, as we have not provided any end index, it will print till the end element of the array and step size will be 2. If I run this, you will see the item starting from first index is nothing but 5. 7 has not been printed here because my step size is 2. 7 will be skipped and 9 will be printed again, and that is what is happening here. So from 5 to 7 is the first step, 7 to 9 is the second, and each second step will be printed as per my slicing criteria. Now, as we have understood how to create multidimensional arrays in NumPy and how to access the items of those arrays, let's see how can we change or set new value of an existing array. We can use assignment operator in order to set a new value of a particular index of an array. Here I am changing the first index of array from 5 to 10. Let's run this first. If you see now, earlier the first index had 5 in it, but now as we have changed and set a new value of this particular index, it is showing 10 now. In this way, using assignment operator, we can set new value of an existing array index. Let's see what was there within array underscore random. The array underscore random had this array. Now I want to set a new value of index 0, 1. That means 44 will be replacing 57 of this array. Let's run this and validate our understanding. Here, as you can see, 57 has been replaced by 44. So, using assignment operator, we can set a new value for a multidimensional array. Now let's understand how can we copy an array to another array. The naive approach is to use assignment operator in order to create a new array from an existing array. If you see here, I have created array underscore random underscore copy from array underscore random array. Let's see what is the value of array underscore random underscore copy. We are getting the exactly same value what array underscore random had. However, this kind of copy is known as shallow copy. Shallow copy has a basic limitation. In case of shallow copy, only one set of memory locations will be allocated for both these arrays. That means this array will be stored in our computer memory only once. And that memory location will have two names. One is array underscore random underscore copy. Another is array underscore random. Both will be pointing to the same memory location where this two-dimensional array has been stored within our computer. And that is the reason even if I change a particular item of array underscore random underscore copy, in this case, we are changing the value of 0, 0 location. This change will also affect array underscore random array. Why? Because as we have explained, there is only one copy of this array and both array underscore random underscore copy and array underscore random are pointing to that same memory location. Even if I change a specific item using array underscore random underscore copy, that will affect array underscore random as well. This is known as shallow copy. If I want to create a totally different array by copying the content of another array, we have to go for deep copy. Using copy function, we can perform deep copy. Here in this case, if I run this, there will be two different memory locations to store the same content in our computer. One set of memory locations will be referred by array underscore random underscore copy. Another set of memory locations contains the same content, but it will be referred by array underscore random. And that is the reason now if I change a particular item of array underscore random underscore copy. For example, in this case, I have changed the value of 01 to 0. However, array underscore random still has the same value 44. So by changing a particular item in one array is not affecting the other array in any way. This is known as deep copy. Let's understand the takeaways from this session. Now we know what is multidimensional array in NumPy, what is the use of multidimensional array. We know what are the different ways by which we can create multidimensional arrays in NumPy. We also have seen important functions and attributes we can use in order to handle multidimensional arrays in NumPy. We know what is shallow copy and deep copy. Hope you have enjoyed the session. Thanks a lot for watching this video.